explaining about intermediate operations in streams. We have number of intermediate operations in streams. Among all those, I am explaining top 16 intermediate operations. If you don't know what are the intermediate operations and how to work with them, this video is for you. So let me write an example for each one, each intermediate operation. Then you will get an idea how to work with that intermediate operation. So let me start with filter. So filter, the name itself indicates that to filter some input source. Input source, it may be collection or array or stream itself. So if you want to filter data from that input source, this filter intermediate operation is used. Let me write an example for that filter. So here I am trying to provide input source for that filter is int string. So let me create int stream of integers of, I am trying to give random data like 9 and 12, 15. Now input source is ready. Now I am trying to apply filter intermediate operation. Filter intermediate operation is expecting predicate. Here my input source is int stream. That's why here we are using int predicate, special case of predicate. So how predicate will work? It will take any type of data, but it will run always boolean. So what I am trying to do here, logic like I am trying to find all factors of number 3. So let me try to implement that. If any number from this input source is divisible by 3, then that is the factor of 3. Trying to collect to a list. So here int stream is returning primitive type of data. So primitive values collections won't accept. That's why first we need to convert to wrapper objects. Then we can try to collect it as a list. Collection of integer data. So let me try to assign to a variable. Let me try to print that data. Let me try to maximize the console. So these are the factors about 3. So here I am passing input source is a stream of integers. Among those all integers I am trying to find all factors of 3. Finally I am converting the primitive values to wrapper objects and I am collecting it as a to list. List of integers here. So let me split into multiple lines, then it will be more readable. Boxed also intermediate operation along with filter I am using here. To convert primitive values to wrapper object, we can use this boxed intermediate operation. So let me start with the next one, that is dropWhile. dropWhile and takeWhile are the intermediate operations are introduced in Java 9. Anyway, I am covering with JDK 8 intermediate operations. So dropWhile will work like it will process the elements whatever input. Once the condition got fails, it will stop the execution and it will return till now processed elements. So let me write an example, then you will get idea. So here again I am taking input source is int stream. I am giving integer data here. So now I have input source is ready. So now I am trying to apply dropWhile. So dropWhile also expecting predicate. Both takeWhile and dropWhile is expecting predicate. So here the input special case will be integer. That's why we are this dropWhile is expecting int predicate. So here I am trying to build a logic like I am trying to filter all even numbers. So when you are trying to learn new concepts, start with some simple logics. Once you have proper knowledge on that concept, then you can start complex logic. That's why I am explaining here with simple logic called filtering even numbers by using dropWhile. So finally again I am trying to collect it as a list. So here again the problem, int stream is returning primitive values, you need to convert to wrapper types, then only you can collect it to collection. Let me try to assign to a variable here, do proper alignment. So here I can rename like dropWhile result. So let me try to print that result, then I will explain how internally exactly it is working. So now let me run. So if you can observe here, it is returning data from 7 onwards, even though first 3 elements are condition satisfied. I mean 2 divides by 2 we will get remainder 0, 4 divides by 2 we will get remainder 0, 6 divides by 2 we will get remainder 0, but the result contains does not contain the first 3 elements. Why? Because dropWhile will work like it will keep on trying. Once the condition is satisfied, it move forward. Once the condition fails, it will stop execution immediately, then it will return next portion of that input source. Here at element 7 the condition got failed, immediately stop execution, then it will return including failed case also, it will return it remaining source. So that is the internal working mechanism of dropWhile. So let me write example for takeWhile. TakeWhile also exactly similar to dropWhile, but the difference is once the condition fails, takeWhile will return till processed elements until unless the condition becomes false. So let me copy paste same example. Then you can observe the difference. So here I can rename like takeWhile result. Here I need to modify it like takeWhile. So let me try to assign to a proper alignment. Here also I need to update output, I mean sys out. Now let me run. So if we can observe, takeWhile is returning satisfied conditions only. So 2 is divisible by 2, 4 is divisible by 2, 6 is divisible by 2, 7 is not divisible by 2. That's why condition at element 7 it is failed. So immediately it will stop the execution and it will return till now processed elements. So this is the internal working of takeWhile. So let me write an example for map. So map is used to do some processing logic for each and every element inside that input source. So let me write list of strings. With that I can explain how map exactly works. So here I am trying to do, I am making string of integers. So now I have string of integers. What I am trying to do, each element present inside that list I want to convert to a integer. So I need to do some operation for each and every element present inside that input source, right? That's why I will use map, then I will convert to integer. Let me write here, I can say list of numbers strings. So let me take this reference. So try to apply stream. Then now I will apply map. Map is expecting function. Any type of input it will we can pass. Any type of output depending on logic requirement we can provide. Here what I am trying to do, I am trying to do parsing whatever input coming from that input source. So I can give it as a reference variable name as string. Then I am trying to do parse int teacher dot parse int of corresponding string I am passing. So let me split into multiple lines for readability purpose. So once I have that, I mean I will convert, once I converted from string to integer, I am trying to collect it as a list. Here directly I mean without box I am applying to list. Why? Because this is the collection type. That's why box is not required. Let me try to assign to a variable. Here I can rename like list of numbers. So let me try to print that result. So list of numbers. So from strings to I convert it as a list of integers. So once we have that stream, from stream, here I have collection data. So any number of intermediate operations I can call depending on my requirement, no problem. Here again I am calling map like each number I am trying to do multiply itself. So again let me run. So each number I am trying number times number. So again I can apply filter also. So what I can do again here, I will filter again even numbers. So let me run one more time. So here I get, once I multiplied with number times number, first I am trying to convert from string to integer. Then I am doing map like multiplying the number itself, and again I am trying to do filter like all even numbers. So this is the use case about map. Next, let me write example for map to object. Map to object is a special case of map. So when you are trying to convert from one data type to another data type, this map to object is useful. So let me write example like I am trying to pass input is a string, then I am trying to find each character is repeated how many times. So here I am trying to give input as my channel name. So input string is ready. From that string I am calling cats method. It is returning int string. So from that int stream I am using map to object to find each character is repeated how many times. So here I am calling map to object. Here I have all integers. From that integer to I am trying to convert character. So next I am trying to collect. So by using group by intermediate operation, each character is repeated how many times I am trying to find it. Collectors dot grouping by first parameter is function I am trying to use here. From that function I am calling identity static method. So if you don't know about default methods and static methods present inside function, I already make video, watch that video. So then you will get some idea. So second parameter I am trying to give here, it is counting. So counting also from collectors. Now I am trying to assign to a variable. So map of character and second parameter is long. Let me try to assign in proper alignment. Here it is. This type error. So now it is looking good. Let me try to print that result. Instead of collect, I can give it as a char count. So here if we can observe, G is repeated 2 times, R is repeated 2 times, and M is repeated 2 times. Remaining all are 1 time. So this is the usage about map to object. If you want to convert from any data type to some other data type, in that special case you can use map to object. So next let me write example for FlatMap. FlatMap also special case of map, but here input source is collection of collection like list of list. Let me write one example. Let me create one collection like list of lists. Here I have list. In that list again I am trying to give couple of lists. Let me duplicate it. First list, second list. Let me try to update the data. And here also. Now my collection object is ready. Try to assign to a variable. Here I can call it as a list of lists. So from this list of lists, my target is I want to convert it as a single list. So let me print it how it is looking like. So here you can observe list of lists. My target is list of integers. So I can implement that logic by using FlatMap. So take this reference, apply stream, then apply FlatMap intermediate operation. So from that from that stream I'm getting collection of lists. For each list again I'm applying stream. So then I am trying to collect it as a single list. Let me assign to a variable. Next I can give name of list of integers. So now let me print it. Before how it is looking, after applying FlatMap how it is looking like. So let me print it. So now I got, instead of collection I converted it to list of integers by using FlatMap. So let me split into multiple lines. So this is the use case about FlatMap. Next, mapToInt. FlatMapToInt. FlatMapToInt also special case of mapToInt. So I can build a logic like finding sum of all numbers present inside that list of lists. So let me do that. Applying stream, then applying FlatMap to int. FlatMapToInt. So here again I am getting lot stream FlatMapToInt. Sorry, here once I got integer. I think here we don't have. Again, we can't apply stream. Here what I am trying to do, map to int. Yes, we can apply stream also. So even though anyway it is a special case of integer, right? List of integers too. I am converting it as a primitive values. From that primitive values also I can apply stream. Then map to int special case. Here I am trying to call one of the method present inside integer wrapper class called value of. So finally I am calling terminal operation called sum. So try to assign to a variable. It is still giving some error. Let me split into multiple lines. Map to incompatible types. So yeah, now it is looking good. Let me try to assign to a variable. Yeah, I already assigned to sum. Now let me try to print that sum. So I'm getting sum of all these integers. So this is the usage about FlatMapToInt. FlatMapToInt is special case of FlatMap only. But if you are trying to convert it to all integers and do some processing logic with that integers, then the FlatMap is recommended. FlatMapToInt is recommended. This is the use case about FlatMapToInt. Next, let me write an example for parallel. So parallel is used to do logic in multi-threaded environment. I mean your logic is executed in multi-threaded environment, then parallel is recommended. So let me write this logic only. I mean here list of list, right? Here this one. So I want to convert this logic into, by using multi-threaded environment I am trying to execute this logic. So let me implement that. This part is not recommended for now for this example. So let me split into output in multiple lines, then you can observe how it is exactly it is executing, and single threaded or multi-threaded. So inside that lambda expression more than one statement are there. Return is mandatory, and moreover that I am trying to write and sys. So to find the currently executed thread name, so for that thread dot current thread dot get name, it will return currently executed thread name. So let me try to run. So all three are executed in main thread only. Why? Because still I did not apply parallel. So let me apply parallel. So now we can observe one of the thread is fork join full, worker thread. It is internally it is created thread with the help of parallel intermediate operation. So my recommendation is until unless if you have proper proper requirement, then only use parallel. Otherwise parallel will impact on CPU usage, so it will impact on performance issues you will get.